Hi, welcome to our next video on parametric differentiation. Remember, parametric equations are pairs of equations, one for the x-coordinate and one for the y-coordinate, which often use a third variable, t for time or theta for angle. To differentiate parametric functions, we're going to use the following chain rule, which says differentiate the y function with respect to t, and differentiate the x function with respect to t, but flip dx dt upside down and multiply these two functions together. The dt's cancel, leaving us dy dx. Right, quick look back at an example to show you how this works again. Let's differentiate the parametric functions x equal to 2 sine t and y equal to 3 cosine t. This parametric equation forms an ellipse. All right, we're going to differentiate the x function. Sine differentiates to cosine, so we get 2 cosine t. And we're going to differentiate the y function. Cosine differentiates to negative sine, so we get negative 3 sine t. If we take dx dt and we flip it upside down to get dt dx, we get 1 over 2 cosine t. Now using the chain rule, dy dx is equal to dy over dt times dt over dx. Well, dy dt is negative 3 sine t, and dt dx is 1 over 2 cos t. So when we multiply these and simplify, we get negative 3 sine t over 2 cos t. This is the gradient rule for this ellipse function. Right, well that's the first derivative, so let's move on and talk about the second derivative for parametric functions. So d squared y over dx squared, that's the notation for the second derivative, and it's equal to, we're going to differentiate the dy dx function with respect to the t variable and multiply it by the dt over dx. Right, let's go back here and figure out what information we have so far. We have dy over dx. And what we're going to do is differentiate this function with respect to t. We also have dx over dt, and we've flipped it upside down to get dt over dx. So let's move on and create the second derivative for this set of parametric equations. So dy dx is equal to negative 3 sine t over 2 cos t. We're going to differentiate this function with respect to t. So let's do our working over here. This is dy dx, and we're going to differentiate that with respect to t. Now it's a quotient function, so we've got g over h. So g is equal to negative sine t, and g dash is negative 3 cos t. H is equal to 2 cos t, and h dash is negative 2 sine t. So when we put it all together with the quotient rule, we get the differentiated function of dy dx with respect to t is equal to negative 3 cos t times 2 cos t minus negative 3 sine t times negative 2 sine t all over 2 cos t all squared. Now this simplifies down to negative 6 cos squared t minus 6 sine squared t over 2 cos t all squared. Now this is equivalent to the differentiation of dy over dx with respect to t. We've also worked out dx dt, and we've flipped it upside down to get 1 over 2 cos t. So let's put that all together to get the second derivative. So d squared y over dx squared is going to be equal to our differentiation of dy over dx with respect to t times dt over dx. And when we multiply and simplify it all down, we get this second derivative function. Right, pretty tough. Go back and try and review the video and then get stuck in and practice as much as you can. Great, thanks for watching.